classification and the evaluation. The k-nearest neighbor, the k-nearest neighbor is keep the name of the techniques. One technique, very, very basic for the classification. Okay. So right now, we are still in the supervised learning again. Supervised learning, and you have learned about the regression already. You just know about the regression and the application and many things about the regression. Okay, we're going to focus on the classification. Yeah. The classification is like you want to predict the output as the category, like cat, dog, fruit, the kind of fruit, and so on. Okay, it is the category of the prediction output. For example, if you have this is the overview process of the classification. You have to prepare the input, okay, and the input is not only the number in the table, but sometimes the data is also the image, okay, like the apple and durian. Okay. Have you ever tried durian? You don't like? I haven't tried durian. Yes, you should try. But some who like durian? Who hate durian? Yeah. We have only like 2% type like and hate.
Like and hate.
Because it's very, very bad smell. Somebody don't like. But it is the fruit that is quite expensive than the other fruit. But you should try one time. And you can feedback to me. Like or don't like.
Have you seen? Have you?
Yeah, okay. And then you have the data set like this, and the next step, this is the data set. Okay, if you remember of the machine learning, we have the circle of data and circle of the features. Okay, the data is might be the image or sound or text and so on. Okay. Okay, and then when you have the image, you can extract the feature. The feature is like, okay, maybe you can extract the color, because in terms of the image processing technique, okay, if you have learned about the digital image processing, the red one, blue one, or any color, this can be changed to be the numbers. Okay, and also you can take some techniques of the digital image processing to find the shape of the object, like how many pixels around the object, and then you can measure the diameter or the number of pixels, and then you can convert to be the numbers. And also the texture inside each object, you can also extract to be the numbers. So everything about the data you can extract for the number, like color, shape, and so on. Okay. After you extract all of data set, you can have the label. Okay, like apple. This is the label, and this is the features. Okay. After you correct all of feature list and all of the label list, okay, it means you have the data set already. So you can use this tool for learning. And you can take a label with the extract data and let it learning. The learning process, okay, it has a lot of technique. The chapter 8 that we're going to learn today is about the k-nearest neighbor, it's the KNN technique. It is the very basic one, but in the next time of our class or the next topic, we're going to talk about the neural network. Okay, it is the one more advanced technique of the classification. But actually the neural network or ANN, it's not only classification, but you can use the ANN model for regression also. both of regression and classification is can be applied in the neural network. Okay, but okay, we're gonna focus on the classification today. Learning. After learning, okay, learning, you can get the model, right? You can get the model. And you know, when we get the model, we should know the model performance, right? It's good, bad, or so. Okay, you have to know the solution to measure the performance of the model. Okay, assume that the model is return you the good performance. Okay, it's ready to use. Okay, if the model ready to use, when you have the new data is not included in the training set. Okay, it means you have the new data set or new data. Okay, sent to the model. The model can predict the output is the apple. But okay, sometimes if the model is bad, maybe it's gonna wrong predict like this is durian. If it's durian, it means wrong. Okay. So this is the whole concept of the machine learning for classification. Okay, classification. And this is the list of the classification techniques. KNN, ARA techniques, decision tree, support vector machine, artificial neural network, and so on. Okay, it's the kind of the classification. And each one it has the individual mathematical background. Okay? For example, today is very simple one. It's just like the distance measurement as similar as the K-mean clustering. Yeah, like only use the Euclidean distance calculation. But if you talk about the Neve techniques, the background of them is my related about the conditional probability, the conditional probability mathematics. And so on, if you talk about the other techniques, you have the different kind of the mathematical background. And I could not teach you all techniques, you know, we have a lot of the techniques, but I will give you the concept and give you some example techniques. And, you know, everything is the same one. You just declare input and label. Okay, it's depend on your feature. If you can extract the features, you can get more feature, and you just change the learning process like KNN or decision tree or support vector machine. It depend on what the model you want. But the concept or the step is the same. You just change this one and get the different models. So that's why I could not teach you in all of the techniques, but you can learn it by yourself. If you understand the concept, you just study by yourself about each one, like mathematics background. Okay, the step of the classification in Python that you have learned just now about the regression. But it gives the similar to the classification. You have to import the data set, okay, very important, and then imply the data set. Yeah, imply the data set, it means like you splitting the data for training and test set, right? Also, maybe sometimes in some application you have to do the standardization or normalization before going to training the data. Okay, this is the preparing data. And the step 3, learning model or creating the model and testing. Yeah, and the last one, we should know about the evaluation of the model, the model performance. Yeah. So this is the 4 main steps when you apply the classification step in the Python. Okay, this is the data set, one example data set from the diabetes. Do you know the diabetes? The diabetes. Maybe it comes from the Indian database. in this database is correct,
Yes,
like
of course.
the PREG pregnancy, how many times the number of pregnancy is the number length is 0 to 17. I don't know, maybe it's the normal situation in India. Yeah. But maybe in Thailand, maybe 0, 1, 2, 3. I think maximum is 5. But maybe it's the normal case in India. And the plasma glucose, okay, the length of number here is the blood pressure, skin, tricep skin for thickness, yeah. So on, okay, we have a lot of data from the patient come to test the diabetes. And the last one, the class is like the test with these parameters, the tested and they get the negative or positive. Okay. Test positive is mean that person have the diabetes. Yeah, but the negative is mean the normal. So everything here is returned to the number. Everything, the text or the every information is turned to be the number. Yeah, like this. And when you have the large of data, it's gonna show something like this. Yeah. And, okay. As you can see, the green one, I try to separate the features. Yeah, features. And the red one is referred to the label. The label is mean positive or negative. Okay, someone return one is mean positive. Positive is mean they get the diabetes. And 0 is mean the normal one. So it is a similar step of the regression, right? In regression, you have to declare the input, like the features, and the label is like the output. Okay, and then in having data, okay, to make you more understand, because just now you just learned about the splitting data set, right? So this is the example to make you more understand. When you have the data set, okay, just now, like this, you have the data set example here, okay, features and the label, okay. When you split the data set, it means you can split into the training set in the blue one, okay. Training set consists of the X train and Y train, yeah, like the feature and its label, okay. And test set is the training the feature and its label, okay. And normally, as I told you, we can separate it into 70% and 30% for training and test set, or sometimes 80% or 20%. Okay. Actually, it's just mix about the numbers. But these two numbers or these two ratios is the traditional one for separating the data set. Okay. And we know already why we have to separate the data set, okay, because we need the fair solution for evaluating the models. Okay, we still have the time, so I would like to explain about the concept of the K-NN technique. Okay, so right now we know we understand the data set that we're gonna have in the example, and we know how we can separate or split out the data set. The next one we should know about the background of the K-NN techniques. Okay, the K-NN techniques is look like this. Okay, I will explain you. For example, the K-NN is come from K nearest neighbor. Okay. If you see the graph, this graph, it has the two classes, B2B class A, and the green one. Okay, for example, the green one, the triangle green one is the class A, okay, and the class B, okay, I refer to the star, the red star, okay. And if you have the new data, it's in the yellow one. you want to know this data, it should be the class triangle or the class star. Yeah, this is the concept of the KNN. The KNN concept is trying to measure the distance. Okay, measure the distance of the unknown data to each data that you have. And also, KNN techniques, it is the lazy learner. Who are lazy learner in this class? No one. Everyone have the active learner. Lazy learner is mean. Lazy learner model is mean. You know the model. If we talk about the model, like the linear regression just now, or the polynomial or nonlinear regression like now, just now, that's we learn. The model should have the equation, right? When you train the model, you get the model, it means you get the equation. But the lazy learner is mean this model don't need or don't have the equation. They just use the distance function calculation. It doesn't have the final equation. Okay, so what is the background concept I'm going to show you now? Okay, so let's take a look. This example, okay, step 0, we have the feature x1 and x2, okay? When you have like weight and height or weight, then you have two parameters for consideration and plot it to the graph. And then you know the label. In this case, we have 3 labels. Okay, the labels of the orange, the label of the green, and the label of the yellow one. And now we want to know the gray one or the new data point here should be the class of yellow, green, or orange. Okay. The concept, the next step, we have to measure the distance, okay, from the unknown data to every point, okay, by using the Euclidean distance as the same as the K-mean clustering technique. Okay, and sometimes some calculation they use the Manhattan distance equation. It is similar, you know. You can select which one, yeah, because it also measures the distance, but the different equation. Okay. So if you measure the distance, you can get the distance number to each one. Yeah, it's a different number. Okay, step 2. After you measure the distance for each point, okay, you can get the like 2.1, 2.4, 3.1, 4.5. Okay, it comes from the Euclidean distance calculation. Okay, you can point the gray one to the yellow one, gray one to the yellow one, gray one to the green one, and so on. Okay, if you have 100 data, you have to measure 100 times. Okay, and you get the 100 output. Yeah, and after you get it, you have to order the distance from the minimum to maximum. Okay, you have to arrange the data of the distance from minimum to maximum. Okay, and step 3. Okay, after you arrange the data from minimum to maximum, it is the time for voting, vote the labels. Okay, for example, okay, vote, but okay, you have to define how many K first, because the name of technique is K nearest neighbors. Means how many first shortest distance around each cell you want to consider. For example, if you select K equal to 3, it means you you are considered about the first three shortest distance. Okay. In this case, if you go back here, you can see that the first three order that shortest is mean this one, and this one. Okay. When you vote, it means how many class in the first three one. For example, this is the 2 times of the yellow, right? If you consider only first three labels, there are 2 yellows for voting and only 1 green. Okay. When you voting the labels, in this case, you can see that the yellow one is the winner. Okay. So if the yellow one is the winner, it means this point it should be assigned to the yellow class. Okay, the yellow class. Okay, this is the concept of the KM, KN. Okay, very easy. The problem is, okay, let's take a look at this one. If this is the one pain point or one thing that you have to concern. Okay. For example, okay, you have to. For example, this one is has the 2 classes. The red one. Okay, you have the red one class, and you have the blue one class. Okay, and then you want to know the green one. The green one would the green one should be the red class or the blue class. What happened if we set the k equal 3? If k equal to is mean you want to concern about only 3 shortest distance. You can see this circle. Okay, it is the only 3 labels is in this circle. So how many times of the red one? 2 times, right? And 1 time for the blue one. So who are the winner? The winner is red one. Okay? So it means the green one it should assign to be the red class. Okay? Okay. As same as the same data, everything is same. Okay? But we just change k equal 5. Okay? So you can see the external circle. We have 5 points around the green one. And if you count it, you can see that the blue one is the winner with the 3 times of blue one, the 2 times of the red one. So if you change the number of k, it means your prediction also sometimes change. Because when you assign k equal 3, the answer is class A. But if you change the k equal 5, the answer is class B. Right? So this is the one thing that you should consider about the number of k. Which number of k is suitable? It's similar to the k-mean clustering, right? We have the technique for like the elbow plot, right? To finding the number of k that is suitable. But this one is different, but it should be considered. But we have another solution for testing the suitable of k. Because you know when you change in k, the answer is changed. Which one is correct, A or B, right? Let's think about the example of the diamond. Okay. If you apply the KN, okay, and you set the k equal 3, and you have the data you correct, and your model predict as you have the diamond with the k equal 3. But when you change the k equal 5 and you test with the same data you have, but your model predict like you don't have diamond. So, right? So I have diamond or not? Because the model, when you change the parameter of the answer is changed. gain in calculation. Okay, this is the example of calculation when you have the data set of dielectric, and I showed you before. You have the many columns for the feature and one column for class. And then assume that you have a data set from the patient. And you have one data as unknown. You want to predict it's going to be dynamic or not. So how we can calculate? So you have to measure the distance from x. X is mean unknown, right? To d1, right? X to d2, x to d3, and until the last one. So from the Euclidean distance, you can calculate it like it's like 5 minus 6. This means 5 here, and 6 here, 139, 148, and so on. To the last one, to the last column, you can get one answer for the distance here, and then you move to x, between x and d2, measure the distance again. You have to do like this in every process, and then you get the answer. You get the answer like x to between x to d1, you get this answer. X to d2, you get this answer, and then you get the all answer. In this case, if you define as k number 3, it means you will select the first shortest distance. The first one here, 99.6, and the second place is the first one is 63, and the second place shortest is 99, and the third place is 142, and then you have to refer each class. For example, D3, the the class 0, and D6 class 1, D8 class 0. So after you know the class, you have to vote. In this case, the winner is class 0. The class 0 is mean test positive. This is the advantage and disadvantage of the KNN. Very simple. Can be applied to the data from any distribution. Good classification if the number of samples is large enough. And the disadvantage is that take more time for classifying new data. If you have 1 million data, and you have new data come to your system, you have to measure 1 million times of your distance and align the minimum to maximum and select only first 3 or first 5 distance, right? So it might be take time. And choosing K may be tricky. You have to find ways to select the suitable K before using the model. And give the large number of the data set for high accuracy. As we notice, we usually define number of K as odd number, not even number. Why? Why we should use odd number like 3, 5, 7, 11, 9? Because it's easy to find the winner, right? For example, if we set K equal 4, and when you vote, for example, you get the 2 times of yellow and 2 times of green. What should we do? If I want to select the event number like 4 and it's vote like 2 times of yellow and 2 times of green. Do you have the idea for decide the winner, like green or yellow, it should be the winner. Do you have an idea? If you want to select the winner, because we have the winner only one. Yeah, let's think about if you are the programmer, you have to think about who are the winner. You can write the coding by your idea. Okay, maybe you can think like finding the average. For example, if we have two times for the green one, right? The green one, it has the two distance. You find the average and represent that distance to be the green. And we have the two times of the yellow. Find the average of the distance. And then we define that which one is shortest, green or yellow. We can decide like, is it the winner or not winner. Or another idea, maybe we don't want to find the average, but you select like, okay, maybe, okay, this is 2.1 and 2.4, and maybe this is the green one as 3.1, and this also green, for example, this green 4.5, so you can select the shortest. If the shortest distance is yellow, is green, yellow is the winner. We don't care about the second place, third place, and so on. Okay, we care about the first place. In case of we cannot find the winner. Yeah. And any idea, you can put your idea to finding the winner in case of you use the event numbers. Okay. But normally we should set the number of games as odd number. I think enough for today's content. Just the new content is like the model evaluation that I'm going to talk later in the next week, and also I will talk about the implementation in Python for the next week. But don't forget to do your homework. And okay, next time I will talk about the assignment tool. You have to pairing your partner, maybe the same partner as the assignment one. I don't know, it depends on you. Okay? And next time I will assign you the assignment to like the YOLO, as I told you last week, the YOLO. Yeah, this one. You can visit the website and study the YOLO. And you know that if you click on the model, okay, you can see that we have a lot of models. Like the V4, V5, till right now, V12, but it's extended to YOLO E. I still don't know about this one because it's very fast technology. Maybe 1 year is had 3 versions in 1 year launch. Yeah, it's very fast for study. Maybe, I will give you like the study and talk to me and teach me because I don't have enough time for learning many things. YOLO is come from real-time seeing anything. Is the new advancement in the silver shop. Comfortable YOLO model designed for open vocabulary detection and segmentation. Unlike previous YOLO model, limited to 3 categories. Wow, YOLO uses the text, image, or internal vocabulary prompt. Wow. Oh. Actually the previous version of the YOLO, it has the limit of the class you can detect. If you want to detect a human, it's going to be detect human only human. In this case, in the introduction, they said like you can prompt, you can select the object you want to detect. Right? Yes. YOLO use text, image, or internal vocabulary prompt for the real-time example code, how to train it. Okay. So the next week, okay, I'm gonna assign you. Let me think about the assignment.